Let's go for another aspect. Now lock in whatever you understood and keep it aside. The second aspect. There is a big heap of bricks lying, and you are asked, create a wall. Create a room. Why wall? Create a room. Bricks are given to you. So you start thinking, okay, I have to create a room. Your mind will start. You will start picking up bricks and making it. That can be your style. Then some more experienced person will say, no, wait, let's think. Are the bricks enough? If not there, then let's wait for bricks to come. And then all UML diagrams will come. Sequence diagram will come. Especially if it is ISO 9000 and CMM. Everything will come properly. And then the bricks will go and the wall will be made. And the room will be made. Ultimately, the room is made. Whichever way it's made. Actually, for the client, the room is important. Not the way it is made. Yes, the room is made. Now, inspired by your performance, the client says, and that's what is happening with Indian companies. You made a room. Very good. Now you make a mall. And unit of construction, brick. Now think of it. At one end you are seeing bricks, and on the other side you are visualizing the mall. There is a big difference between engineering and science. An engineer is looking in a future. Science looks at the world which is already there. Doctors look at the body which is already there and analyze. We as engineers, we as developers, we as software developers, we create things. And that's where fundamentally our thought process differs. And that's why here we are talking about software design and design patterns. Because we are creating something. Now you will say this brick is such a small unit of construction. No, I don't want to take up the project. I will not take up. Then somebody says, do one thing. I give you ready-made walls. Then will you construct them? That is easier. Because I have to just place walls, customize it a bit. Parameters have to be there and then should have the shape and color. Only click. And then you can create the building. It becomes more convenient. What has changed? The unit of construction has changed. And then somebody can come and tell us what has changed. Wall is ultimately made up of bricks. So ultimately using brick. But as day-to-day workers, we know there is some difference. This fellow is saying correct. That everything is made up of atoms. This is atom, this is atom, I am atom, you are atom. Now this I cannot invalidate. This is correct. Up to 1920, science was believing that go on cutting the hole, go on cutting the hole, go on cutting the hole, come to the component. And if you understand the component, trace back and you will understand the whole. After quantum physics entered, everything was smashed. Why? We need to understand this as developers. As developers I am saying, not as physicists. The finding was that we cut the water molecule into atoms and we cut atoms into nucleus and then try to understand each part and then why we are doing this? So that one day we can understand what water molecule is. That's the whole idea. So first understand the component and then we'll understand the system. And for that cut the system into components. But after 1920, as quantum came in, many new physics principles were expounded. They realized that they could not trace back certain characteristics of the system to components. The system was exhibiting certain characteristics and I cannot trace it back to the component. Where is this characteristic coming from was the question. So water is exhibiting characteristics which cannot be traced back to hydrogen and oxygen. Where are they coming from? And we all will like the answer. The answer to that is that the characteristic is not coming from the components, but it's coming from the organization, the pattern in which the components are organized in the system. It's the pattern which is giving the characteristic. Why I am telling you this? I am telling you this because a function is not merely a collection of fors and ifs and else. A wall is not merely a collection of bricks. A heap of bricks is collection of bricks. But a wall is a pattern of bricks. A function is pattern of for and while. And that's why It is having something more than merely the statements. And this is where you should remember the whole is greater than the parts is realized here. I'll cut the whole thing short. See, we went from brick to wall, and then somebody can give you ready-made rooms also, and then somebody can give you ready-made buildings also, and we can create whole Bombay. You can easily relate. As software developers, we started it, of course, which were very small. The software went on becoming big. Then we found out for loops and if else and whatnot. We can agree one for loop is equivalent to several machine codes. Then that was less. We are talking of unit of construction. And then we went for functions, which were larger unit of construction. Functions fall short. We went for objects. Object is still larger unit of construction. Now objects are also falling short. So we need a higher level of unit of construction. My next proposition is, agreed, pattern is a solution to problem in context. That's one aspect. But more practically, pattern is a unit of construction. It's a building block which is larger than an object usually. It may be a combination of few interfaces, classes and object. And don't consider it as a mere collection of classes and objects. Then you are making the same mistake pre-1920. No, it's not mere collection of classes and objects. It's a collection of classes and objects organized in a particular way and solving a purpose. So pattern is a unit of construction. Well, so now you know that you can use pattern to solve problems, because functions are always better than for loops to solve problems, and objects are better than functions. They are larger units. Wall is better than brick. So as the software is going more complex, we need larger units of construction, hence patterns. Okay.